Folks, thank you very much for joining us for the first session of a BMP Summit. This session, all the topics was prepared with the input from the BMP core team, and some of the speakers are actually from the BMP core team itself. So thank you very much for joining in. Today, we have a first speaker, Dr. Tom Obreza, for development of fertilizer recommendation from IFAS, and we have a pre and post test for it. So Emily, if you can go for the pre-test, that'll be great. You folks have 1 minute to answer all these two questions, and then we'll go from there. All right. I think most of you has attempted the test. Thank you very much. All right. So I would like to welcome Dr. Tom Obreza for the presentation on developing fertilizer recommendation from IFAS. Dr. Obreza.
Thanks, Lakesh, and thank you for inviting me to participate today. You gave me this topic of developing IFAS fertilizer recommendations, and here's kind of my lightning round of topics that I'm going to try to cover in 20 minutes or less. If there's one thing I'm good for, it's a historical perspective, because I've been around a long time, and you know, it's sometimes easier to understand where you are today, you know, when you understand kind of what got us here. So I want to touch on that a little bit. As far as recommendations, you know, who does it? How do they do it? PNOC is Plant Nutrient Oversight Committee. The origins of PNOC. The last few years, Senate Bill 712 has changed the game. And then the PNOC Renaissance is what I'll finish up with. So I'm not a hoarder, but I do keep historical documents of interest. And I had this one in my file from way back when I collected my grad student days of the first record I had of IFAS recommendations for, and in this case, I'm using field and forage crops as an example. This goes back 45 years to 1977, and when you look at the multiple page document, which was printed on yellow paper on purpose, I guess, because yellow paper stands out in your file, and that means it's important. And so they always printed these on yellow paper back in the day when it was all about fact sheets. But you know, you look at the table of recommendations, and if you're familiar with SL 129, you know, which is our publication we use now, table's not all that different. It has evolved and changed, and you know, added some things, but really the format goes back this many years as far as how we present the summary of fertilizer rates and some management aspects associated with them. An example I can point out here is if you look at irrigated corn at the highest plant population, the nitrogen recommendation back then was put 60 down around planting and then come in with 180 later on in one application for a total of 240. So keep 240 in mind as we kind of go through this. One aspect that I do want people to understand is this gets to the who does it question, and you see 6 names here on this document that's just field and forage crops. Back in the 70s and 80s, we had greater capacity across a lot of our departments for faculty to do this kind of soil fertility nutrient management work. And there are 6 names you can see on this author list here. I happen to know 5 of these people. And one of the interesting things is David Wright, whose signature is there, is still an active faculty member in the agronomy department at NFREC Quincy. And so you got a connection all the way back to a current individual who's still working in this area. But there were more people back then now that did this kind of work than we have at the present time. Going forward about 12 years to 1989, still on yellow paper, and the fact sheet format, this changed into a notes in soil science, still the same good old table. They kicked in some pH recommendations and then started to code in the footnotes that took the fertilizer rates that are shown in the table towards how you would manage those fertilizers, particular aspects related to certain crops that the recommendation was related to. The irrigated corn line is kicked up to 30,000 plants per acre, but you can see the nitrogen rate is 240, just like it was 12 years before. But now we've gone down to 3 individuals who are putting this together and making these recommendations, or responsible for them. Gerald Kidder was a holdover from 12 years before. Ed Hanlon, one of my mentors back in the day, he ran an extension soil testing lab. That's the job that Rama Irrelicu has now, and Carol Chambliss. And so we went from 6 to 3. Now fast forward another 30 years or so, and you get to SL 129, which is our current document where the summary is kept. And you do see 3 individuals who are on this field and forage crops recommendation guide. Dr. Maya Irrelicu is the main curator and person who keeps track of all this stuff. David Wright is there, and Gerald Kidder is there, although Gerald, he's got a historical tie to the document. Jerry retired probably close to 20 years ago. So, it's really down to Rao and David on this one. But you look at the table again, and going back to the past, it still doesn't look all that different. And so we haven't really evolved too much in the way we present the information. We do have, there's the 30,000 plants per acre on irrigated corn, and the 240 is still there. So nothing has changed over that time. So the next question is, and I've alluded to this a little bit, is who does all this stuff? Who gets involved with setting these recommendations? And the simple answer is it's IFAS Research and Extension faculty. If you remember back to that 77 document, all 6 of those faculty had extension something in front of their name, extension agronomist or extension soil specialist, and so it's those individuals that we have in those roles now, as well as researchers that may not have an extension assignment, but are still contributing to the body of work that we use to develop the recommendations. They particularly come from about 4 departments in our REC, soil and water science, agronomy, hort science, and environmental hort. Again, relating back to the past, when I came into the department as a student, it was the soil science department, period. And there were numerous faculty who were doing soil fertility research back in the day. And they don't have nearly as many as those now. And in hort science, used to be 2 departments that used to be vegetable crops and fruit crops, separate departments, with horticulturists that were also doing this kind of work. So just another kind of example of, how things have consolidated and IFAS has evolved in the way they hire faculty and what their assignments are. So as some of those fertility nutrient management people had left and retired, they weren't really, replaced to the same volume. I do want to, emphasize though that our REC faculty play a big part in this because, they're working in the industry and they've got places they can do field work and develop, research that will also contribute to the crops that are pertinent to the area where the RECs are. So it's always been a collaborative effort between Gainesville faculty and REC faculty. As far as the how goes, there's really never been a specific written procedure describing how to do it. Got to have the research, got to have something to base your recommendations on. So the faculty used research results from their own studies and studies of colleagues, and maybe even around the Southeast for crops that are grown outside of Florida. But there's also this aspect of best professional judgment that comes in when setting fertilizer rates, plus the other 3 R's of the 4 R's concept, that we kind of like to think of as far as it's not just the rate, but it's how you manage the materials and the water as well. I liken best professional judgment to like if you're building a puzzle and you have all the pieces and you start to construct the puzzle and you kind of work on the edges first and then you kind of work towards the middle. And at some point you get an idea of the big picture, even though not all the pieces are there. We have a decent body of research to draw from, but there's not a research project out there that's published that answers every question that we have. But as you start to kind of integrate all these things together and, look at that puzzle as you're starting to fill in some of the holes, the picture kind of becomes a lot clearer, and understanding the production system and what the requirements are and all the various factors that go into, determining what the fertilizer rate is. That's where, what I call the best professional judgment aspect of setting fertilizer rates and management practices. So, we don't really have a record of that thought process unless you talk to some of the old timers and how they did it. But, what do we have in terms of the body of work that we can actually go look up? And we've got referee journal articles out there, peer-reviewed articles, research reports, and even some unpublished work, where faculty have drawn, their information from to develop these rates that end up in that table. So, where do we go to look at that? If you're trying to figure out, piece together, how did we get to this point? You can go to these articles and it's not the whole story, but it's a large part of the story, that we have, not only the research papers, but some of the extension publications that were produced in the past as well. The gold standard of what we like to see is, the national or international journals, which is the real comprehensive, high quality stuff that our faculty do, agronomy journal, SSSA journal, ASHS journals, and the like. But one of the valuable bodies that we had in the past, not so much anymore, was our state societies, FSHS, which still exists, and also Soil and Crop Science Society of Florida, which unfortunately does not exist anymore. That went defunct in the first decade of this century because the interest just kind of waned in it as faculty were, shooting for higher profiles and higher publications. But SCSSF and FSHS was another repository for a lot of the information that we use to develop the recommendations that we have today. So how do we do it? Back to that, before around 2000, the responsibility was on individual faculty, mostly extension specialists who maintained or updated the recommendations. They would produce these fact sheets or publications, EGIS documents, special publications, production guides that they took responsibility for. And a lot of that was group work, horticulturists, agronomists, soil scientists all working together, to produce these things and come up with the recommendations and the consensus there. But it was on those individuals to do that, and people were doing their jobs. But one of the problems that we ran into that was pointed out to us back around 20 plus years ago was that there was a lack of uniformity across IFAS. As you can imagine, sometimes scientists disagree. And there may be one fact sheet that said X and another one that said Y, and perhaps one of them came from a different part of the state, down south from an REC or something like that. And we got called on that, relative to, hey, I got 2 publications in my hand here. This one says this, and this one says something different. What's the story? You guys can't get your story consistent. And so that was an issue, particularly, as environmental concerns were increasing, and people were really looking at our fertilizer recommendations a lot harder, even from people who were not producers, but people were more concerned about environmental issues. And so that led to the development of the PNOC, Plant Nutrient Oversight Committee, which was established around 2000. It was a group of researchers, extension specialists, and administrators that was called together by the deans for research and the dean for extension under the authority of the senior vice president to have authority over IFAS recommendations and how we handle them. And so, one of the main goals at the beginning of PNOC was just to assure the uniformity of IFAS recommendations. And one of the things that developed from that was statewide recommendations rather than regional. There was some cases of that going on, which simplified the thing, yet there was perhaps troublesome to some who, look at the idea of that maybe our recommendations should be regionalized for, specific purposes. They do that in other states, on a kind of a gross basis. If you go to look at Georgia recommendations, they have separate recommendations for Piedmont versus coastal plain, because the soils and the environments are a lot different. And, could we or should we go to something of that nature, and what would that look like? That's something that we're, perhaps thinking about now. But PNOC, became the gatekeeper then for recommendation changes. It wasn't just up to the individual faculty then to decide, I'm going to change this recommendation, I'm going to put out a new fact sheet or a new EDIS, that it had to be run through PNOC as the gatekeeper to make sure that it was legitimate and science-based. And so faculty then from that point on had to, present the case to PNOC to say, I want to change this recommendation. It's justified because of this research I did and these other things. And so, frankly, there wasn't a whole lot of that activity in the last 20 years. There was some, a handful of approved changes since 2000. I can think of citrus, I can think of sugarcane, and most recently potato and cabbage, kind of went through that procedure. But PNOC is undergoing the Renaissance study indicated, and for, various good reasons. And one of the main ones was Senate Bill 712 that put the spotlight on our recommendations. Now, our recommendations, by design of the BMP program, have always been the BMP. If you're doing the BMP, you will do IFAS recommendations. But, for many years of that program, growers were never checked upon to see if they were actually doing them or not. 712 changed that, and so that got a lot of people concerned about the validity of what we have now under current production systems and different germplasm and new varieties and those kind of things. Are our recommendations still legit for, you look at that 240. That 240 goes back to for irrigated corn, high plant population, goes back to 77. It hadn't changed since. Does it need to? That's something that we're going to be looking into. So PNOC is the authority now then that maintains the internal consistency of our recommendations and also ensures the scientific integrity of them, because we've never been sued over a recommendation that an environmentalist thought was too high, but that could happen someday, particularly around springs areas and those kind of things. And so if we were ever taken to task on that, we've got to be able to support our recommendations with science based on biased information. And that's really one of the big roles of PNOC to make sure that is solid. So the roles going forward for PNOC are to prioritize the commodities and the nutrients that we would be looking at, mostly nitrogen and phosphorus. Set the standard format for a recommendation. Should we go beyond the tables and the footnotes that we have now into something that's a little bit more elaborate, that integrates the 4 R's together a little bit better than we do now, and I'm in favor of that. Develop the process and set the criteria needed to update or change a recommendation, and then provide the sanctioning of changes that faculty would propose. But it still continues to this day that PNOC will rely on the faculty as the hoop who will be doing this. And so there's the individuals out there in these various departments and RECs who still have, that responsibility as part of their job in nutrient management, soil fertility, and those kind of things to work on that. The reason why we've lagged in that area is, frankly, it's been funding, not only the capacity, the people that we have, but the money available to do that kind of work, which has not been very much available in the past 10 or 20 or 30 years. Agencies don't want to fund, fertilizer rate work or straight, work that gets down to the kind of some of the things that we need to do. Federal agencies will not, and the industry has trouble doing that too. But we cannot make changes without new research. Fortunately, FDAX has been funding some BMP projects that are going to help us, in recent years. But the latest thing is in the current state budget that the governor has yet to sign. And Scott Engel, our VP, has a lot to do with this, as he's done listening sessions with growers, expressed his concern, taken it to our friends in the legislature, and the result of that was actually more money than we asked for, but more than $8 million of funding on a line item for IFAS to work on fertilizer rates, nutrient management, and BMP research. It's non-recurring. It's for the coming year. Scott Engel believes that we will get future funding in the next fiscal years. It'll just have to be maybe done 1 year at a time rather than getting recurring funding. But that's a lot of money to spend. That is unprecedented. I've never seen anything like this before. And we're in the process now of figuring how that's going to work, because it's got to come through FDAX, AES, Ag Environmental Services, and then subcontracts to our faculty that will actually do the work and get started. So that's where we are. Dr. Sharma, and I think I used up all my time. I don't know if there's time for questions or not, but thank you for the opportunity.
Thank you, Dr. Obreza. We can take one question, and there's a post test for this presentation. Please fill this survey too. It helps us to improve our programming. We have 1 minute to spend on this post test. Thank you, Emily. This is the QR code for CEUs for this presentation. Every presentation has its own CEU. So if you need any credits, please use this code. We have a sign-in sheet too, if you want to. Right. Okay. All right. Thank you very much for filling this survey. Okay. If you have any question, we do not have time for that at this time, but please keep your questions, and I will get back to you with those questions at the end of the session. Our next speaker is Dr. Kelly Morgan. And Dr. Morgan gonna tell us about some success stories that BMP has till date. There's a lot, starting from Dr. Brian Bowman. Thank you, Dr. Kelly Morgan. The floor is yours.
Okay. Well, thank you very much. I'm kind of in the same situation as Tom talked about.
Dr. Morgan, sorry to interrupt you. We have a pre-test, folks, so you have 1 minute to fill this survey as well. Sorry, I should have mentioned that earlier, but this is the test for pre-test for this presentation. Please fill this. We have 1 minute. All right. Thank you, Dr. Morgan. You can start your presentation. We have the survey fill.
Okay. Great, thank you. Well, as I was saying, I'm kind of in the situation with Tom. The history or the perspective of different programs around the state go to the to the guy that's been here the longest, and I have a track record with IFAS, goes way back, and with BMPs as well. So I agreed to do this kind of history perspective and some success stories, talk about for the BMPs. I want to thank Stuart Swanson for helping me with this. He contributed a lot to it, and I relied heavily on an archive of slides that Tom Obreza set aside from Brian Bowman and Eric Simone and others. So BMPs in Florida go back to 1995 with a citrus issue that came up from a EPA and Florida DEP project started in the early 90s, looking at nitrate issues in shallow drinking water wells around existing groves. Nitrates were well above the state standard for drinking water, and wanted to know what could be done about that. What was the cause initially, and then what could be done about it. And the fingers were pointed at the groves themselves, the fertilizer practices within the groves, and that the groves were contributing to the nitrates in drinking water. So in 1995, a group of researchers at the CREC in Lake Alfred put together the first BMP, which was all of 4 pages long, on what were the best fertilizer practices to avoid leaching of nitrates or reduce leaching of nitrates in sandy soils on the ridge. And this was basically a culmination of research that had been done for the past 30 years prior to 1995, and by Koo and Whitney and Wheaton and others. So that simple, relatively simple 4-page document lasted until the mid-2010s when the citrus manuals were consolidated. At one point, we had this 4-page document plus 3 other full BMP manuals just on citrus. One for the upper ridge, one for the Southwest, one for the East Coast. All of those were combined into one document, and that did away with the 4-page document. So our manuals have changed a lot in the last 27 years. So in BMPs themselves, the program was accelerated in 1999 to a statewide program under Office of Ag Water Policy. And that was the Florida Watershed Restoration Act in 1999. And that basically was the basis of the current BMP program, in that manuals had to be approved by regulation or by recognition that they have some basis in science on how to properly manage nutrients, and that put a lot of emphasis on IFAS recommendations. Then in the 2000s, the DEP became lead agencies to develop TMDLs. TMDLs was an attempt to look at existing water contamination, surface water contamination, and what were the contributors to it, in addition to agriculture. So certain amounts of nutrients, mostly nitrogen and phosphorus, entering surface water was contributed to different different industries. Industry itself, maybe sewage treatment, as well as agriculture. And so the TMDLs were divided up among these different sources, and Ag was told that we had to reduce our allotment of the TMDLs over a period of time, and BMPs was the way that they chose to do that. In the next few years, from 2007 2015, IFAS became the lead to do educational programs within the state. And at that time, the group that was doing it was led by Brian Bowman out of the Indian River REC in Fort Pierce. He had a dedicated group of people that represented different parts of the state and did educational programs in that part of the state. And I'll talk a little bit more about that specifically in just a moment. 2008 to about 2010, we had BREC, and I'll talk a little bit more about that. But that group came together. It was an interagency group that included University of Florida to look at coordinating BMP research and extension. 2010, the BMPs became quasi-regulatory with basin management action plans developed by FDEP. And these were plans, as I mentioned before, to look at TMDLs and how agriculture could lead the way in developing best management practices to attempt to reduce nitrogen and phosphorus entering these surface water bodies. 2016, the water bill passed and required that BMPs, that growers were mandated to enroll in BMPs in the BMP program if they were in a BMAP. Prior to this, it was discussed as being voluntary from the very beginning in the late 1990s to about 2010 to 2015. It was considered a voluntary program that growers could sign up if they wanted to or not. 2010, with the basin management action plans, that changed a bit. It was highly suggested that they become or they enroll in BMPs, but 2016 mandated that growers within BMAPs and in the Springs area enroll in the BMP program. So it evolved from a purely voluntary program to one that was more regulatory in nature. And then, as Dr. Obreza mentioned, SB 712 came, and that really mandated that the BMP program become a truly regulatory regulatory program, in that the growers were required to provide information on nutrient management on their farm. And that's kind of where we are as far as a historical perspective of BMPs. Now, to talk a little bit about the extension programs, some of the research programs, we'll go forward here. IFAS has split these programs up into agricultural and urban. I'll talk just about the agricultural portion of that in this presentation. I mentioned BREC. BREC was a new model that was one that really should have led the way in BMPs, and was thought that it would. This was about 2008, 7-8 when this came about, and BREC is the acronym for BMP Research Extension Coordinating Committee. And the committee was made up of FDACs, FDEP, IFAS, and then the 5 water management districts. As Dr. Obreza mentioned, FDACS and to a small extent FDEP has been providing most of the research dollars for nutrient management work, but the water management districts have provided some funding specifically to water management, but in light of making nutrient management more efficient. How do you manage the water so that you're not leaching nutrients past the root zone? And that's where all of this came together. The idea was that there would be a coordinating committee. The amount of research dollars would be out there on the table, and then this group would decide what the priorities were for the research dollars. The 3 representatives from IFAS was Brian Bowman, Tom Obreza, and Eric Simone. They were known as the 3 amigos. If you don't understand that reference, it was a comedy movie by that name, and so that kind of stuck with them. And you can still get a laugh out of them if you mention that to them. But this I mentioned previously that this only lasted a couple of years, and that was primarily because of the economic downturn in about 2008-9. The state budget didn't allow much money from FDACS or DEP to provide money for research, and the committee kind of dissolved. But it was brought back by FDACS a couple times, or at least attempted to, and there's some remnants of this still in existence. I also mentioned the program BMP Implementation Team that was led by Dr. Brian Bowman. This is a listing of the people that were part of that program. You can see that there's 7 people listed here. These people were fully funded just to do educational programs on BMPs and to help or to assist FDACS in enrollment of growers in BMP programs. So this went on for probably 5 or more years. They did a lot of very good work, a lot of good demonstrations, both in field and on RECs. This kind of went away in 2015 with the water bill, and when FDACS took back most of the enrollment portion, this program was not funded. And so we have what we have today, which is the BMP educational part, which is, as far as BMP programs are concerned, that's where IFAS is right now, is purely educational. Beyond the research that we have for nutrient recommendations. So that has been taken up by statewide programs and by extension faculty statewide, and doing a very good job of doing the educational part of this program. I mentioned BMP manuals earlier. This is an older slide, so there are more BMP manuals than this, but FDEP is responsible for green industries and golf course manuals, and they have developed those. FDACS is responsible for agriculture. I mentioned the three citrus manuals, and you see versions of them, or the covers of them there. Those were all consolidated in about 2014, 2015 into one manual. The other manuals have been developed. The goal of these manuals are to update them every 5 years or so. Typically, it's a little more than that. before we get around to revising them. But they have changed a bit over time. Many of these manuals, particularly the citrus manuals, were notebooks just full of information, very specific information on how to manage nutrients. Now the BMPs guides from FDACs refer quite heavily to IFAS publications to get that information. So, and this was done on purpose so that as new information comes, as recommendations change, IFAS can update those recommendations or update those publications, and they can still be tied to the BMP manuals. So we'll talk about some success stories here for the rest of this presentation. I got a lot of this information from some past slides, but also from Office of Ag Water Policy and the water management districts. The majority of the success stories involve improved nutrient use efficiency, reduced fertilizer use, increased water use efficiency, and sustainable yields. That's that's BMPs in a nutshell. So a lot of these programs have dealt with efficiency, how to improve the efficiency, and improve nutrient use in the process. A lot of the work has been done on the local level. This slide talks about BMP implementation in North Florida around the Swanee Valley area. A lot of work has been done there going back around to 2000 or the late 1990s, looking at the 4 R's, how to develop nutrient programs with the 4 R's in mind, looking at timing of application, placement of application, and the materials, as well as irrigation in this area. A lot of work was done with dye tests, injecting dye into drip irrigation. Drip fertigation was promoted with these kind of programs. The dye test was a very visual way of showing growers exactly how deep water goes with one application. So that if you apply too much or too long, you can put fertilizer well below the root zone. And so this type of programming is very important and has benefited BMPs greatly.
Morgan,
one industry that
we have 1 minute for you.
Oh, I'm sorry. Okay, I'll conclude with this slide. The one of the industries that has benefited a lot from BMPs and BMP success stories is citrus, and they're looking at irrigation management and fertilizer management, use of precision application equipment, and developing more precise fertilizer applications. So with that, I'll end, and if I have time, I'll be glad to answer any questions.
We have a post test. Emily, if you can, yeah, thank you very much. We have 1 minute to go over this post test. At the same time, if you have any question, Dr. Morgan can answer this we have a CEUs for this presentation as well, if you are looking for credits. Please put your answer on the post test. right. Our next speaker is Dr. Sudeep Sidhu. We can end. We have a pre-test for Dr. Sidhu as well. Please, in front of your screen, there's a pre-test for Dr. Sidhu's presentation. If you can answer those questions, that will be great. Dr. Sidhu, we can just wait for a minute and then we're gonna start. Okay, Dr. Sidhu had joined recently at Swanee Valley NFREC Live Oak Station, and Dr. Sidhu going to present on sensor use for nitrogen management using Ndvi. Dr. Sidhu, stage yours.
Can you hear me, Lakesh? Can you hear me? All right.
Yes,
Well,
yes.
Thank you, Lakesh. And I'm just asking you before I start my presentation, do I have till 10 o'clock or will I get some extra minutes so that I...
You will get 3-4 minutes extra.
All right. All right. Well, the topic of my presentation is NDVI, sensor-based nitrogen management. And for this presentation, I'll primarily talk about nitrogen calibration strip. And this is the technique that I started working on when I was working with Dr. David Wright for the last 4 years at NFREC Quincy. And the picture that you see on the slide is the beautiful campus of NFREC Quincy. Currently, as Lakesh mentioned, I recently joined as Regional Specialized Agent in Agricultural Water Management at NFREC Swanee Valley, which is located in Live Oak, Florida. So I will not go into the details because Dr. Morgan talked about all these, history of state legislature involvement in very detail. But what I would like to emphasize here is that there is a push from state legislature for protecting Florida's water quality. And it has been noted again and again that contribution from farm fertilizer in nitrate loading in our BMAPs is significant. For example, in Jackson Springs BMAP, farm fertilizer contribution is noted as 79%, and for Swanee River BMAP, the farm fertilizer contribution is about 60%. So that puts a lot of pressure on us as faculty members to come up with improved methodology, improved BMPs for efficient nutrient management, as well as emphasis on us as faculty members to expand our outreach program to educate our growers to follow proper procedures when they are applying fertilizers. So the first step in site-specific nutrient management is to capture your field variability. In my research, I started using various MSP3. It's a GPS-enabled state-of-the-art technique and equipment that can capture on-the-go soil electrical conductivity, soil pH, soil organic matter, the slope of your field. So I used this to map our fields as the first step. The one important thing when we use our various MSP3 is when you run various across your field, it will just give you a range of high versus low, and those are relative readings. So if you look at the picture on your right-hand side, that's how your various raw data comes out with a range of color from a white shade to different shades of gray to a dark color. So the important step here is that you go back and then you collect your soil samples from all these different colors. And because all the data is geotagged, so it's really easy to go back, collect your soil samples, and then based on the actual numbers for your organic matter, for your soil texture that you collect at different spots, various data is calibrated to give you actual field maps. So this is the first step. Now, once we were able to map our field into different zones, now the obvious question was like how to determine in-season end rate for each zone. And this presentation is for all the research that I did in cotton, starting from 2018 all the way till last year. So we have a field now, which we know that it has different soil properties, but now the obvious question is how to determine what nitrogen we need to apply in one zone versus in another zone. And that's where the calibration strip came up. So the way we establish calibration strip is that once we know that what is a grower standard rate, which, for example, in this particular demo farm, the grower traditionally, or Dr. Wright always recommended a rate of 60 pounds of nitrogen per acre, which is 67 kilograms per hectare. So to establish our strip, we went a few rates lower than 67 and included 67 and went a rate higher than 67. And the way we established the strip is that it is established right after cotton planting, as you can see in these pictures. So these pictures are from one of my trials that we established back in 2019. So we established our calibration strip using granular fertilizer, and we hand banded it right after cotton planting. Now, since I've been talking about calibration strip, and I've been asked a lot of questions by interested folks about how to establish nitrogen calibration strip. So the first thing is that you establish the strip right after planting or within a few days of planting. And the reason is that we want all that different incremental rates of nitrogen that we applied as part of the strip to undergo the same environmental conditions, moving on from the day the crop is planted all the way to early squaring or early bloom when we make that in-season determination. Now, another question that I got asked is that, do we have to have a liquid applicator or a granular nitrogen fertilizer to establish the strip? And the best answer is you can use any. The best answer would be if a grower wants to or is interested in establishing a strip, if he has a liquid rig, he can establish it with his liquid fertilizer. If he, if he is comfortable with, applying it through a granular fertilizer, apply your strip with granular fertilizer. But you cannot sling, you cannot sling your fertilizer or broadcast it with a slinger and apply your strip, because then you will mess up your rates. Is banding preferred to broadcasting? Yes, from the context of best management practices, I would recommend that when we establish the strip, we establish it as a band application. I would also emphasize here that for a grower to establish a strip, the grower should follow whatever the grower is comfortable with. In our case, we went with about 20 to 20 feet of a plot length for our each rate within the strip. And we also always tried to be on the 6 rows, on the same 6 rows on which the cotton picker would be picking cotton at the end of the season, so that we don't mess up, if we need to use the cotton picker for harvest, so we don't mess up the rows. So these are only the considerations when we establish calibration strip. Now, the next important question is that once we have established the strip, now how will that strip help us in determining the in-season end rate? And for this determination, we used sensors, or we used Ndvi meters. So Ndvi is a ratio of near infrared wavelength and red wavelength. So the formula to calculate Ndvi is NIR minus red divided by NIR plus red. So it's been documented over and over, and Lakesh has done a lot of work on sensors as well before coming to, before joining University of Florida. So it has been seen that if your plants are healthy, those plants would reflect a lot higher quantities of your near infrared radiations than if your plants are stressed. So in our study, we used a handheld Ndvi meter, and to be persistent, we got the reading, the Ndvi rating from the top 4th leaf, or the top fully opened leaf. And for you all to understand how Ndvi or visual quality ratings helped us determine the in-season rate, look at the illustration on your right-hand side. So these were, for example, if 0, 34, 50, 67, and 101 kilograms per hectare nitrogen were our rates applied as part of our calibration strip. And now we are in that time frame of squaring to early bloom. And if we see, and different green colors here in that illustration show us the response to nitrogen. So if we see a response all the way up to 67 and no response beyond that, so that means that for this particular season, for that particular zone, 67 is your in-season rate. You shouldn't be applying more than that. Now, a second illustration. So for example, in another zone, you do not see any response beyond 50, which means that your Ndvi ratings were similar, moving on from 50 to 67 to 101. It means that there is no further response to nitrogen at early bloom beyond 50. So 50 should be your in-season rate. Now, from 2018 to 2020, we tested the calibration strip in one of our demonstration farms located in Greenwood or Mariana. We collected data, and we knew that the strip has recommended us rates and was helpful in reducing our in-season nitrogen rates by up to 50%. And I have a publication on that research published in Crop Science. But the next step for me was to test the calibration strip across Florida Panhandle to consider different cropping systems, different soil types. And so we chose, and initially we chose 3 locations in Jackson County. The fields in Jackson County are, if you are looking at the Google map, are under that blue square. So we had 3 fields: Hatcher West, Greeble, and Bullfrog. And then in Jefferson County, we selected 2 locations, which was Alford's Place and Bishop Field on the Google Maps, shown under that green square. For some reason, the cotton planting at one of these locations at Bishop Field was very sporadic, and we collectively decided to discontinue the study at Bishop Field. So at the end, we were just left with 4 locations to test the strip. Now, one thing I would like to share with you all here is that the location in Jefferson County, which is Alford's Place, was the only location that was non-irrigated and was behind winter grazing. All the other locations, Hatcher West, Greeble, and Bullfrog, they were all irrigated cotton, and they were not behind winter grazing. So basically, if you see this table, you will see that we were testing the strip on different varieties on the same field in different zones, on the same field. We were testing it on irrigated land, which was not behind winter grazing. We also tested it on non-irrigated cotton, which was behind winter grazing. So a lot of interesting data was collected last year. So for the sake of this presentation, I'll discuss only 2 locations, one from Jackson County and one from Jefferson County. So let's start with one of the fields, that is Bullfrog Field in Jackson County. So we mapped the east side of the field. And if you can see, we got clear-cut distinct 2 zones, the dark zone on the south side, the lighter zone on the north side. So the dark zone represents where the soil texture is heavier, and the light zone represents where the soil texture is coarser, which means more sand. Our strip and treatment plots were established on 6 rows, and our treatment plots were 183 meter long, which means they were 600 feet long. So one of the interesting things here is that last year's calibration strip testing was done on actual farms, and the plot size was not a small plot research, plot size, it was long plots. So and cotton was picked by a cotton picker. So it's more representative of what actual yields would be. Now, this is the plot layout from one of the zones in Bullfrog, and the plot layout was similar for all the locations. So if you're looking at this plot layout, look in the area that's covered under that red rectangle. So that is block 1 or replication 1. So at the bottom, you see there we established our strips, control, and then all different rates of nitrogen. And then after our strip was established, we had those long treatment plots where we applied in-season strip recommended rate on these 6 rows, and on that adjacent 6 rows, the grower applied his rate. So that's how the plot layout was. The only thing to emphasize here is that our treatment plots were long plots, 183 meter long or 600 feet long, but our calibration strip plots were actually 20 feet long plots. Now, this is another location in Jefferson County, Alford's Place. So we ran various, and we were able to get 2 distinct zones here: the dark zone, the finer texture dark zone, and a coarser textured light zone. Based on how the zone gave us the space to work on, we were able to establish our treatment plots, which were 91 meters long, which is actually 300 feet long. So one thing I mentioned it in one of my previous slides, and that was that the nitrogen rates or incremental rates of nitrogen within the strip is based on the grower standard rate. So for Hatcher West and Griebel, the grower typically applies 205 kilograms per hectare nitrogen in Jackson County. So our strip rates were below that rate and beyond that rate, and it was similar for all the locations. And I want to emphasize it because this is one of the questions that I get very often, that are the rates in a calibration strip standard for all locations? And the answer is no. You have to know the history of the field, and then based on your soil test and the history, you come up with your rates for different locations. Now, how did NDVI help us and visual quality ratings help us to determine in-season nitrogen rates? And these are the graphs from Bullfrog location. So we were able, as I said, that we have to hit the plateau beyond which rate we don't see any further response. So for zone 1, we didn't see any further response beyond 118. In zone 2.
Sorry to interrupt you. We have 2 more minutes for you.
All right. Thank you, Lokesh. So in zone 2, we were not able to hit that plateau. So we were just left with choosing the highest rate. But based on the graph, it seems like we were hitting the plateau, but we didn't hit the actual plateau. So we chose 135 as our rate. So for Alford's Place, we hit the plateau at 84 for zone 1, which is the darkest zone. And we hit the plateau at 67 rate in zone 2. Now, for cotton lint yield from results from Bullfrog, so the strip recommended rate, which was 118 in the dark zone, versus grower applied rate, which was 140, there was no difference in the yield, and we were able to reduce nitrogen by 15%. And for light zone, where the strip recommended rate is 135 and grow recommended rate is 163, we did not see any difference in the nitrogen in the yield, but were able to reduce nitrogen by 17%. So for Alfred's place, let's look at the graph on the right-hand side. For the light zone, we were able to reduce the nitrogen by 33%. But if you see that the control and the other two rates, statistically, there's no difference. And the same now come back to the left-hand side. Control yield was actually numerically higher than the plots where we had our in-season rates. And the question is why? So the answer to that might be that the control plots were smaller plots, so they were not picked by the cotton picker. So they were hand-picked, and as we all know, hand-picking cotton bumps up your yield, and the control plots are so small, a little bit bump on that 20 feet of a control plot would extrapolate to a large change in the yield. So technically, I shouldn't be sharing or showing this data and having a control plot right next to the others, because I'm not comparing apples to apples, because the way the cotton was picked was different. So in the end, I'll quickly ask you all to think about it. Does the end rate number really matter? We all have been talking about the end rate number, but is the number important, or is it important that how we applied that nitrogen? So think about it. And that's the end of my presentation. Thank you all. And I would like to thank Dr. David Wright for all his support over the years. I worked with him for 4 years, and I'd like to thank him.
Thank you, Dr. Sidhu. There is a post test for Dr. Sidhu's presentation. Please fill this survey. And if you have any question to Dr. Sidhu, please ask. There is a CEU QR on the screen. You can use it for your credits for this presentation. We'll wait for 1 minute, and then we will move to our next presenter. You can ask questions while we are doing this. All right. Okay, so we have done with this presentation. Thank you, Dr. Sidhu, for presenting. Our next speaker is Dr. Vivek Sharma using soil moisture sensor benefits. Here is a pre-test for Dr. Vivek Sharma's presentation. Dr. Sharma, thank you for presenting today. We'll wait for 1 minute and then we'll start with your presentation.
Hello, everyone. Can you see my screen?
Yes, we can see your screen. Perfect.
Thank you, Lakesh, for the invitation to speak in the BMP Summit. So Lakesh asked me to talk about soil moisture sensors, and I believe it's a good opportunity for me to talk about our efforts on the Florida Agriculture Soil Moisture Sensor Network as well. So I'll start my presentation, why we are talking about soil moisture sensor, and at the last I will cover the aspects of the network. I think our previous presenters, Dr. Obreza, Dr. Callie Morgan, Dr. Sidhu, all mentioned the challenges that we are facing in the state of Florida, But if you look at the irrigated side, we even in the all the eastern states that we have in the in the United States, Florida is the one state where we grow specialized crops, right? Even we receive about 45 to 50 inches of rainfall in a year, but most of our specialized crops are highly dependent on irrigation. We irrigate about 1.3 million acres every year in the state on an average. But recently, from the past decade or so, we have seen that there is an increasing irrigated acres across the state. At some places, we have seen some decrease, but at some regions, especially in the Sweeney River basin, we have seen there may be in next decade or so, we'll see about another 40% increase in irrigated acres. That lead to about 4% increase in the crop water use, but again, this number can be a big number as well. At the same time, everyone, previous speakers talked about, the challenge that we are facing on the water quality, intensive agriculture agriculture practices led to a nitrogen leaching concentration, in lakes, in springs, impaired water bodies, harmful algal bloom are some of the challenges that we are facing. So you can see, we are looking at both quantity and quality challenges in the state of Florida. One particular aspect of best management practices is to use the precision irrigation management, which is very important and critical for the state of Florida. Dr. Obreza mentioned 4 R's, and someone told me recently, irrigation management is the 5th R. In irrigated agriculture, even we apply appropriate amount of fertilizer at right place, right time, right source. But if we are using inefficient irrigation practices, those benefits we cannot see. So I choose this as a 5th R, closing the loop as an irrigation management, because we can't afford both excessive and insufficient irrigation management. Excessive irrigation can cause soil erosion, deep percolation of water and nutrient. It can affect our grain yield and quality. This is very important, especially in a setting where we grow specialty crops. Environmental degradation, we hear a lot about this. Increasing pumping cost is another disadvantage that we have with excessive irrigation. On the other side, insufficient irrigation can limit transpiration, that can lead to less biomass, poor grain yield and grain quality, and ultimately affect our net returns. So under all these circumstances, the key definition is here, the precision irrigation management, that tell us how we can control the timing, the amount, and where to irrigate. And with the latest development in the irrigation infrastructure, we have variability irrigation systems as well that allow us to select the zones within a crop field to where we need to apply the water and how much we apply the water, and at what time we need to apply the water. So if we look at the irrigation scheduling trends in the state of Florida, this is from the USDA National Agriculture Statistical Service Farm Ranch Irrigation Survey from 2013 and 18. Yellow bars is representing the trends we seen in 2013 and blue bars in 2018. Still in our state, we can see the predominant method, is the condition of the crop and the feel of the soil. But 2 scientifically sound method that I want to highlight here is, one is based upon the crop ET using the water balance approach. We have seen some increase in the adoption. You can see the blue bar. It's not as substantial, but there is a little progress on that. And other is the soil moisture sensing devices, use of the soil moisture sensing devices, and we have seen about 60% increase, from 2013 to 2018. And there are many reasons for that. One would be, the industry support. We will see in the state of Florida, we have many industries, soil moisture sensing industries that can provide support to growers that use soil moisture sensors. Other is the development of various irrigation web platforms, irrigation apps that allow us to use or manage our irrigation on phones or on tablets, on computers, that really push how we can effectively manage irrigation on farm using the soil moisture sensors as well. And lastly, I can say the cost share programs, which is started by FDACs, water management districts, which allow producers to get those sensors, which are relatively costly at a subsidized rate, right? So these are some of the reasons, why we have seen this increase in the adoption of those sensors for managing our irrigation. if you look at the soil moisture sensor technology, how it evolved over time, we saw, if you go back in 1990s, we see in the gravimetric method, it's still a very sound and scientifically sound method, but it's a laborious method. We have to collect soil sample from the field, dry it in the oven, wait for 24 hours to see how much water the soil contains, right? Other methods like tensiometer, neutron probe are also the old methods where we install those equipment into the field, but we have to regularly check manually what's the readings, right? If we go into early 2000s, we have seen a lot of companies are using the data loggers, where sensors can hook via wires to the data loggers, and then the data logger contain data for a month or 2 months, and there are different sensors that equipped with those data loggers, single depth sensors mostly. And now we are in an era where we have Ag IoTs, where we have better communication solutions, better networking solutions, so that we can get all our soil moisture data or related properties on our tablet or smartphones. And this is really helpful in managing the irrigation on farm. Okay, so there are many companies, these are just few of them, but there are many companies that have their own soil moisture sensor on web platforms, different installation methods. So which company we should go with, which sensor we should go with, So these are the few questions that are generally being asked. But before I go to that question, we need to understand how these sensors operate. So if we leave the gravimetric method, which is the direct method of soil moisture monitoring, where we actually take the soil sample, dry it in the oven, and how much water it contains, but the rest of the methods that we used using the soil moisture sensor monitoring methods are the indirect methods. So indirect method generally use a surrogate property of the soil, and then it relates to the soil moisture or soil water content. All those methods are highlighted here. Even the hand feel method, we look at the property of the soil, whether it is wet or dry, and we'll then make a decision, how much is the moisture. Same with the other technologies that use some other property. For example, electromagnetic sensor use scale frequency or dielectric property of the soil medium, and then correlate with the volumetric water content to estimate how much is the moisture. So among all the technologies, what we have seen that the electromagnetic soil moisture sensors now get a greater push. We have seen these sensors around with the better capability of networking as well, where we can get our data online. Most of those electromagnetic sensors work on a principle of dielectric property of the soil medium. So soil profile consists of soil particles, water, and air, in the pores. And all the particles in the soil medium have different dielectric constant, that is the ability to store a charge. For example, air has a dielectric constant of 1 compared to water, which has a dielectric constant of 80. So you can see there's a big difference between the dielectric properties of the soil particles within the soil profile. So if your soil pores are all empty, filled with air, their dielectric property or dielectric constant is close to 1 or lower, compared to when all the pores are filled with water, their dielectric property is higher, right? 80. So that big difference between these constant values generally used to estimate the soil moisture or soil water content in the soil, in the electromagnetic sensors. One particular type of electromagnetic sensors that we generally see nowadays is the capacitance and the frequency domain. There are other methods as well, for example, time domain reflectometry, but I will concentrate on this because I have seen these methods have been used mostly in agriculture fields as well as in the controlled environment, in the nurseries or in the greenhouses as well. For example, this is a meter sensor, which is also capacitance-based sensor. Centec drill and drop, also a capacitance-based probe, which give you the whole dynamics of soil moisture within the crop root zone, depending upon the length of the probe. So if we take a cut, if you cut a section of this probe and look at the, what's inside this white plastic, we'll see these electrodes. And these electrodes, generally create an electromagnetic field around it and create, and based upon the dielectric property of the soil medium, then use that to estimate the soil moisture of the soil. So there's always some kind of imprecision or inaccuracies exist. Generally, when those sensors calibrated in the laboratory settings generally have better accuracy. For example, if the soil is uniformly packed or it's a controlled environment, but field accuracy reduced as we go into the field because of many factors. Either it can be a different bulk density or different salinity levels. And also the sensor installation. If we install sensor improperly, then we got bad readings that cause the inaccuracies in the soil moisture reading as well. This is just an example of that. This is a study we've done in 2017 and 18. We can see we have about 10 different sensors here. All are varying, both temporally as well as, if we look at its relationship with the standard values. So you can see the significant variation compared to a standard method like a gravimetric or the neutron probe at different depths as well. So we know about soil moisture sensors, and generally being asked, how we can use those soil moisture sensors in irrigation management. As I mentioned, soil profile is constituted of different particles, water, pore space as well. If you want to understand the irrigation management, we generally look at the conceptual bucket plant available water, where I am not going into the different terms associated with that, but what is important is the management allowable depletion. Generally, we need to target our soil moisture above the management allowable depletion so that the crop will not get stressed. And this is just an example. We don't want on both sides, insufficient irrigation and excessive irrigation, as I mentioned, is both harmful. But the idea is, at the beginning of the crop season, if your field is at field capacity, as crop water use, it can reduce the volumetric water content, and when it reaches to the management allowable depletion, we need to irrigate. At the same time, and again, the crop water using and the precipitation, if it happen, your volumetric water content will increase. It drop again, as the crop water use, when you irrigate, it comes to the field capacity, and this process continues. So this is the most of the lines that we see on the, different web platforms operate just like that. We need to manage our water within that safe zone. So the idea is to keep the water content within this range so that we can avoid crop water stress and minimize drainage below the crop root zone. So this is one case study that I want to present. This study we again conducted in a silty loam soil in sugar beets, replicated trial where we have 3 treatments. One is the farmer practice weekly irrigation, checkbook method, as well as the soil moisture sensor based irrigation scheduling. Just a synopsis, what we saw that sensor based irrigation scheduling account for overall saving of 15% compared to the checkbook method, and about 46% compared to the weekly schedule, if we continuously weekly apply water on a regular basis. So these savings are substantial savings. Let's take an example of Dr. Duke's study, that they conducted from 2015 to 18 in Sweeney River Water Management District in a corn peanut rotation study. They have 5 different irrigation treatments. I want to highlight, the blue lines, and here is the orange and gray line. You can see the blue line is the grower standard practice, and the orange and gray line here is based upon the soil water balance and soil moisture sensor. You can see a substantial difference in the irrigation, cumulative irrigation applied. So this study also led about 60% irrigation saving as well. Other things that we need to account for, when we look for the sensors, other is we talked about sensor accuracy, why sensor accuracy is important. But other type is, what kind of soil type we have, whether that sensor is field calibrated based upon your soil type. how many sensors we need, what kind of crop you are growing. All those factors, play a very important role when you select a different soil moisture sensor. So to educate all those things that we talked about, Dr. Charles Barrett actually was the original PI on this, and I took the leadership on this last year on the Florida Agriculture Soil Moisture Sensor Network, where the idea is to provide advanced training to extension agents in the installation and the use of sensor technology so that they can feel comfortable to share the knowledge and skill with the growers. Transfer technology mode, the model that we use is agent that, different agents in different counties or different regions join the network and then recruit farmers for the network. And then as an agent, specialist and farmer discuss how we evaluate data, how it can be applied for real-time irrigation management. And then farmer use those sensors in data to modify their irrigation management, and the last we evaluate the outcomes or impacts of that network. So this is the general model that we are generally we are following in the agriculture soil moisture network. This is just a snapshot of the network expansion. As I said, the network was started by Dr. Charles Barrett in the North Florida with the 16 probes in 2018. And you can see the progress we have made until 2021, 2022. Since the Florida has a very diverse growing season, so we cannot see all the probes at one time. In 2021, 2022, we have 49 probes. Even we have allocated about 80 plus probes across the state. And this network is just not the network of the probes. This is a network of agents as well, because one of the idea is to educate our extension people, extension faculty about how those sensors work so that they can work with the producers. We have seen, I have seen some of the extension faculty and agents are in the seminar today. And I will be presenting lastly, one of the study that Lisa Hickey, conducted in the Hillsborough County as well. So we use different sensor technologies. We are not sticking with one particular type. We use Centec drill and drop, EcoSpy, BMP Logic, but at the same time, we also provide training one-on-one on different sensor types as well. We have coming IST, soil moisture sensor technology on May 6th. We'll be announcing that very soon, but this is the final date that we have decided, May 6th, where we have the perspective of researcher as well as industry, how we can use those soil moisture sensor in irrigation scheduling. This is a study that I want to talk with you. This is in the POP citrus farm in Hillsborough County, where Lisa Hickey was in charge of that, where they saw yellow and lime green leaves, and we thought that it might be a citrus screening. They have 2 irrigation zones, 8 hours period water cycle, rotating continuously, high diesel fuel, fertilizer expenses. This is a pre-irrigation, pre-soil moisture sensor installation scenario. But this is a post-soil moisture sensor scenario where we reduce the irrigation 1 hour per zone twice a week in a sandy soil and 10 hours per 10 days for a sandy loam soil. And that, this small change led to significant savings. We have seen about 45,000 savings in the diesel fuel only. At the same time, producers have seen the highest yield also after the soil moisture sensor installation. At the same time, we have seen the fertilizer reduction by $8,000 as well. So you can see by a small change, installing a couple of probes in the field, managing our water effectively, we can target many of the benefits. Diesel fuel saving, energy savings, yield, high quality, as well as the fertilizer savings. Another success story, we talked about.
Sorry, Dr. Sharma, we have 1 minute for you.
Yes, we have seen the benefits. The other is the institutional collaboration. So recently, Dr. Tom Obreza was also involved in that, where we have developed the collaboration with the TNC, the Nature Conservancy, where they provided 16 soil moisture sensor probes to UF extension agents. in 5 of the counties. And these kind of interactions between IFAS and different institutions also led the adoption or widespread the whole scope of the network. So this was really nice, and the collaboration is going on. We are seeing some good results out of that as well. So I'll end my presentation here. Thank you so much for your attention, and I'll be happy to answer any questions if you have.
We have a post test for Dr. Sharma's presentation. Please fill this survey. At the same time, if you share, okay, here we have a CEUs. If you have any question, Dr. Sharma is available for to answer those questions. So we have 1 minute to fill the survey as well as for the question itself. We will definitely hang out at the end of the session to answer any question. If there is any follow-up on that, please get your questions in line. All right. Okay, so the next presentation is from me on sulfur role in agriculture. Here is the pre-test for that. Please fill out this survey, and I'm gonna share my screen. Everybody can see my screen. Please, I need a thumbs up. Everybody is okay to see my screen?
Lakesh, you're sharing the wrong part of your screen. So we're seeing your Outlook.
Okay, sorry, folks. Oops. Can you see that screen now?
Yes, but you need to go up to display settings and click switch.
Gotcha. For some reason it's not popping up here. Right. I'm the chosen one for this presentation. Okay. Oops. I need to probably close all my other screens to make it work. Sorry for the inconvenience. Is it better now?
Yes.
Perfect. All right, folks, you have done your pre-test survey, so I'm going to talk about the role of sulfur in agriculture. It is the most least understood nutrient in agriculture, with fourth most important nutrient in the chain of 17 essential nutrients. So we have 17, and the sulfur is the fourth most important. The most of the inputs for sulfur in agriculture are from salt sulfur pools itself, organic manure that being used in some agriculture production, inorganic fertilizer, irrigation water, and atmosphere deposition. Historically, the atmosphere deposition was the biggest contributor to the sulfur deposition, sulfur content in the soil. But over time, with the EPA's regulations, this deposition got down, and it is a very small number nowadays. It's the fourth most important nutrient. Sulfur has a role in amino acid. It shares amino acid with nitrogen. The three amino acids that are methionine, cysteine, cysteine, these are very important amino acids moving forward when I will talk about its deficiency. It has a role in formation of proteins and oils and enzyme activity and it has a synergetic and antagonistic effects with other nutrients. So sulfur is a very important, least understood nutrient. In this slide, you can see 2000 on the right hand side. If you see the map in 2000, the Florida, we have, if you can see my mouse, we have deposition in the range of 6. It's kind of a pretty vague slide, blurry slide. I can't see the number, but I can tell you it is every 2 pound increment. So it's around 6 to 8 pounds per acre deposition every year. But in 2019, it's almost close to 0 to 2. So it's a very low deposition. And if we go beyond 2000, the number was between 20 to 30 pounds per acre deposition. So there is a lot of deposition in the past, but now we do not have enough sulfur in our system to support our crop production. And considering the high yielding varieties, we do need a lot of sulfur. And with the Florida situations where the soils are pretty sandy, sulfur leaching is an important aspect to consider while applying sulfur. This is a sulfur deficiency in corn and soybean. It is very similar, as you can see, nitrogen deficiency. The biggest difference between nitrogen and sulfur deficiency is the nitrogen deficiency usually appears at the bottom of the plant. I will call it old leaves. However, the sulfur deficiency appears on the young leaves because it is not movable in the plants. Sulfur fertilizer sources. There are several fertilizer sources that are being used in the fertilizer blend by the farmers. There are gypsum that has a calcium in it as well, elemental sulfur in the southern part of the state to reduce the pH. The pH in the southern Florida is in the above 7.5. So they need to reduce it. They use elemental sulfur. That's the source of sulfur. There are other cheaper sources. The elemental sulfur is the cheapest source, but there are other sources, the bisulfate, thiosulfates, potassium thiosulfate. These are some of the expensive sources along with compound fertilizers. Sulfur rate studies in agriculture. So I want to let you all know that there are not many studies in agriculture related to the sulfur rates. Because this nutrient was never considered as a limitation for the crops, but because of a reduction in the deposition of sulfur and improving high yielding varieties across all crops, sulfur is showing its deficiency among crops. And the recent example is in the cotton in the Panhandle region. The sulfur deficiency was pretty evident there. Okay, so here is 2 studies. One, I did this work in Maine. It's not published yet. It's under process. And there is a tomato study in the past in 2008. And if you see, as you apply more sulfur, there's a response to the yield. But as you apply more and more, it also results in decrease in yield, irrespective of how much you apply nitrogen, phosphorus, and potassium. So in a nutshell, I would say higher application and lower application of sulfur result in decrease in yield. It is also important that it has an interaction with other nutrients that has something like nitrogen, phosphorus, and potassium, and I will discuss it, how it impacts later in my presentation. So this is some of the work that I did last year. You can see the sulfur application in potatoes and 3 different varieties. You do not see a whole lot of difference in the yield, and I come back to why it is the case. Because the most of the growers in Northeast are used to apply a lot of gypsum application, and that is in the range of 2 to 2.5 tons per acre. That is a lot of gypsum that has sulfur in it. So I think the biggest reason of applying gypsum is to get a calcium out of it. So because calcium is important for the skin set for potatoes. But maybe it's a historical practice that growers are following. However, it has now been showing some problems. So in terms of yield, you do not see any sulfur. We applied this sulfur and we did not see any response to it. And the question is, when there is a response in other places in potatoes, why not in Florida? Similarly, if you see on y-axis, this is extractable sulfur in the leaves on trial 1 and 2, and this is on the x-axis the amount of sulfur application, different rates of sulfur application from starting from 0 to 160 pounds per acre. And this is the leaf sampling after 45 days of planting. So you can see that, excuse me, I think this is I'm sorry, I have to correct myself. This is from the soil itself. So you can see that 160 pounds of sulfur application treatment has only around between 20 to 25 ppm of acceptable sulfur. And if you convert that into pounds per acre, this is around 50. So when you applied 160 and you only have 50 pounds per acre left over, the question is where the left of the sulfur goes. And the answer is it just leached down in the soil profile. And there was around 8 to 10 inches of rain a week before this sampling, and all the sulfur that was applied disappeared from the root zone. This is the same soil sampling after 115 days after planting, and you can see that it was 20 to 25 pounds after 45 days, and 115 days it increased. So the question we asked, how the sulfur is increasing in the soil profile when it was leached down after rainfall. So we came up with several sources. We did so much soil sampling, plant sampling, other sources. We did also rainfall analysis, and the biggest source for sulfur we found was irrigation water. So the irrigation water in Hastings and St. Augustine has a lot of sulfur in it, and that is because the farmers are used to apply a lot of gypsum in the fall. And that has a lot of sulfur that leached down and now reached to groundwater, and that sulfur is coming back in the irrigation water and getting the basically a source of sulfur for the potatoes and any other crop they are growing. And this is consistently from one farmer. So this is all from one farmer wells. All 5 wells have high sulfur content, and if you see well 4, it's around 2022. Look at the number in 2020. We just had last year and this year almost 1503 ppm. It's a lot of sulfur in itself in the water. And how this sulfur is actually creating a problem, that's what I'm going to discuss in the next slides. We do not have any ongoing study that could determine the impact. We have some studies in place to determine if the sulfur is impacting the yield if you apply more, but we do not have that data published yet. So I found this a very recent study in 2021, and that's a very good study. And if you want, I can share that publication with you. If you see that the phosphorus and sulfur interaction, and this kind of work may help in answering some of the questions related to the phosphorus in potato region and tomato region. So if the sulfur is on the lower side, if you see x-axis, the yield is low, but as it is increasing, it is also result in decrease. If you see the sulfur at the end of the x-axis on the right hand side is a 30 pound per acre. So the nutshell is for every phosphorus unit, you need a half of a sulfur unit to produce the optimum yield. So if you need one sulfur unit, you need 2 phosphorus unit to improve the phosphorus uptake and improve the crop yield. And that may be the reason a lot of sulfur in Hastings area may be hampering the phosphorus uptake among the potato crop as well. So this could be one of the reasons that need to be determined as we are moving forward. And the second slide, how I'm doing on the time? I'm doing fine. Okay, so the second slide here, you see nitrogen uptake. The nitrogen uptake is increasing as you apply phosphorus and sulfur to the soil, but as it reaches to the highest amount, it starts again decreasing its uptake. So sulfur has an interaction with phosphorus and with nitrogen very strongly, and it impacts the uptake of nitrogen phosphorus. So I would suggest moving forward that most of the agents that work with their farmers to address this issue and include sulfur in their fertilizer blend if they do not have that, and if they are applying too much sulfur in their on their farm, then there is a need to kind of cut back as well. I do not have that number in mind as of now to tell you how much sulfur could be an optimum range. But looking at the literature on several crops, between 30 to 40 pounds is usually look very promising, considering the sandy nature of our soil. This is another P uptake. You can see that as the sulfur application increases, the phosphorus uptake decreases. So you need a very sweet spot for sulfur application when you consider other nutrients uptake. And we are working on it. We are working with the phosphorus, potassium, and nitrogen interaction with the sulfur in Hastings area in potatoes. So I'm hopeful that we would have some good answers sooner than later. The summary of my presentation is the sulfur is definitely an important and essential nutrient that need to be included in the fertilizer blend if it is not a part of any farmer's fertilizer plan. I have included that in a few farmers' fertilizer plan, and they have found positive results. Higher or low sulfur application reduces phosphorus and nitrogen uptake, and that in terms, if that means if you apply more and more phosphorus and nitrogen, it won't impact your yield. And that is because you may have a very low amount of sulfur or very high amount of sulfur in your soil, so that need to be fixed to get desirable results. Lack of sufficient sulfur could result in loss of yield and quality. And we have seen that as the sulfur improves, sulfur content in the soil improves, the yield of the produce improves a lot. So with that, I would be open for any question. If there is any post-test for me. All right, I think we have 1 minute to go for this post-test, and there's the CEUs on the screen for you to consider. And if you have any question related to sulfur, I'll be more than happy to answer those. We have 1 minute to go, and I'll also get to a point for our last presentation from Jay Capasso.
Thank you, Akash.
Jay, I think the post-test for my presentation is done. So Emily, if you can go for the pre-test for Jay Capasso's presentation, that would be great. Here's the pre-test for Jay Capasso. Jay, we will give a 1 minute to everybody for to fill up this pre-test for you for your presentation. And then we'll go. We are running at almost around 10 minutes late, but I think it's not too bad considering 8 presentation or 2 hours.
Okay, well, thank you, Lukash. I'll give them a minute. You can see my screen?
Yes, we can. Thank you.
Okay. About ready to go?
Yeah, I think you are all set.
Okay, well, hello, everybody. I'm Jake Passo. I'm the row crop agent in Columbia County Extension. I'm going to be talking to you today about some control release fertilizer trials we've done in North Florida in the Swanee Valley region. Okay, so in the Swanee Valley region, best management action plans have been implemented for the Santa Fe and the Swanee rivers with a restoration nitrate concentration of 0.035 milligrams per liter of nitrate. So we're trying to cut back on the amount of nitrate in these water bodies. And there's more development all the time in the Swanee Valley region, but agriculture is a big land use as well. So it's one source of nutrients. One tool we've used for managing nitrogen is the use of control release fertilizer in field corn, carrots, and watermelon. So most of these trials have been demonstration trials on farm or trials at the North Florida Research Education Center, Swanee Valley. But I do have at least one producer in my county using control release fertilizer on his watermelon crop. So these products are generally a control release fertilizer. They're a polymer coated urea. And the products that we've experimented at the Swanee Valley Research Center have been Harrell's, Purcell's, and ESN. For the on-farm trials, I believe only Harrell's have been used in the region so far. And these are control release fertilizers that are release dependent on temperature. So with a product like Harrell's, you can apply it at planting with the starter, and it'll stick around for about 3 months for a field corn crop. And Purcell's has been used this way as well. ESN is a product I'll be talking about a little bit during this presentation. And ESN is a shorter product that's more around a 50-day release. And you can see a picture on the right-hand side of the screen, which is a Harrell's control release fertilizer. And you can see the colored coating around the control release fertilizer. These control release fertilizers shouldn't be mistaken with slow release fertilizers, which are often release dependent on microbial activity or hydrolysis. So there are different fertilizer application methods that we use for these trials. The first would be a broadcasting rig. Most of my farmers use broadcasting rigs, and the reason being it's a really fast and easy way to apply fertilizer. You can apply it to about 8 to 12 rows at a time, and you can move pretty quickly throughout the field. So in this case, the farmer is actually applying controlled release fertilizer using the broadcasting rig. Another rig would be the side dressing rig, and each of these hoppers here carry about 1,200 pounds of fertilizer. So it can carry about a little over a ton of fertilizer at a time. And our first product machine is a 4-row applicator that one of my growers owns. So this is a really useful for incorporating the fertilizer and applying fertilizer efficiently by the row. It gets fertilizer down 1 to 2 inches in the soil, but it's a much slower fertilizer application method. You're only applying to 4 rows at a time, and you're probably moving much slower throughout the field than a broadcasting rig. The last rig I want to show you is the Harrell's banding rig. So Harrell's Fertilizer created this rig. I think it cost them somewhere around $90,000 to do it. And the reason they did it is because farmers didn't like having to continually refill their fertilizer hoppers like they had to with the side dressing rigs. So this fertilizer applicator can carry about 5.4 tons of fertilizer at a time. And what it does is it drops fertilizer on top of the row, and then the farmer can come back with a strip till unit and incorporate the fertilizer. Or in this case, the farmer just planted on top of that fertilizer that was dropped on top of the soil surface in the attempt to incorporate it a little bit. This, again, can carry 5.4 tons of fertilizer, so that's a major advantage of it for larger acreages. Another thing I want to touch on really briefly is that with controlled release fertilizers being release dependent on temperature, how you incorporate them may affect the temperature of the environment that they sit in. So if you incorporate the fertilizer, you might have a different soil temperature in the first few inches than if the soil is sitting on the surface of the soil. And Dr. Mulvaney has done some work with the ESN product that I'll be talking about in the upcoming slides, where he's shown that with a broadcasting the ESN, he found different release curves compared to incorporating the ESN. So fertilizer placement can be tricky. This is twin row corn here. This is using the Harrell's banding applicator. And we applied the controlled release fertilizer in a strip in the field, and we went over it with the planter. And in some areas of the field, it looked really good. It landed perfectly between the two twin rows, as you can see in the left-hand picture. But in the right-hand picture, you can see we ran into an issue where it was to the left of one of the twin rows, and that resulted in uneven growth between the twin row corn. So one of the twin rows of corn was growing better than the other. In that same trial and in that same field, it wasn't only the banding applicator that we had placement issues with. We also had placement issues with the broadcasting rig. And you can see in the left-hand side of the picture, you can see the streaks in the field, and the broadcasting rig, which is a totally different piece of equipment, also had some spreading issues where it just was not uniform. So I've never ran into these issues with the side dressing rig. You know, when you get the fertilizer down into the ground 1 or 2 inches of the side dressing rig, it results in very uniform growth. But these are some issues I've run into with the broadcasting rig and the banding rig. So pros and cons of banding control release fertilizer. One pro would be that side dressing fertilizer is a more efficient fertilizer application method than broadcasting. Controlled release fertilizer can be applied in a single application along with the liquid starter application at the beginning of the season. And that's really helpful in cutting back in the amount of times the grower needs to go out into the field. There's a higher cost of controlled release fertilizer, which is obviously a negative. That would obviously be a con, but it does incentivize efficient fertilizer application methods. It's beneficial for growers who are unable to fertigate using the center pivot. I have one grower that's under hard hose irrigation that can't apply any more nitrogen. He can't fertigate because he doesn't have a center pivot. So after 40 days, he can't get over that corn anymore and apply any more fertilizer. So in that scenario, the controlled release fertilizer is very helpful for him in avoiding nitrogen deficiency symptoms later in the season in his field corn. Some of the cons would be that it takes longer to side dress fertilizer compared to broadcasting. And if it takes longer, time is money, and fuel costs and everything nowadays. There's higher input costs associated with side dressing compared to broadcasting, and fertilizer applicator capacity issues, as I touched on, for larger acreages. There's also a higher cost of controlled release fertilizer, which is the main barrier for controlled release fertilizer to be being used on farm, especially on a crop like field corn. And you can see in the picture here, this is from my first trial using controlled release fertilizer. We're comparing side dressing controlled release fertilizer on the right-hand side compared to broadcasting conventional fertilizer on the left. And you can see that the side dress controlled release fertilizer that year started out noticeably ahead. So I'm going to discuss 2 trials today. I'm going to discuss an on-farm trial with a Columbia County cooperator that we conducted in 2021. And I'm also going to discuss a trial that was conducted at the North Florida Research Education Center, Swanee Valley by Dee Broughton. And that's an ESN trial, which is a nutrient product. So the grower cooperator in Columbia County uses hard hose irrigation. And this year we were comparing side dressing controlled release fertilizer to side dressing conventional fertilizer. And you can see that his application methods, basically his grower standard consisted of a starter at planting, a 28-005, 2 side dress applications at 30 and 40 days after planting. And then after that, he could not get over the corn anymore. For the CRF treatment, he used the starter, the 28005, and then applied a Harrell's blend of controlled release fertilizer using the side dressing rig. This is the first year we've compared side dressing conventional fertilizer to side dressing controlled release fertilizer. In past years, we had used broadcasting conventional fertilizer, which was his grower standard practice, to side dressing the controlled release fertilizer. So this is more of an apples to apples comparison this year. So these are the yield results. You can see that these yield results were very low. That's due to this guy down in the bottom here. This is a maize weevil. And we just had a big infestation of maize weevils in his field this year. So we had very large standard deviations and low yields in field 1 because of the maize weevils. So we went back into field 6, where we also had replicates of his grower standard practice and his controlled release fertilizer. And there were not as many maize weevils in this field. And we found yields that were more typical of what he generally gets. And we didn't take multiple yield measurements per replicate, which is why you don't see the standard deviation bars in the field 6 graph. We also measured soil nitrate at the farm, and we did this approximately every 2 weeks throughout the season. And we took soil samples using a soil auger at 0 through 6 inches, 6 through 12 inches, 12 through 24 inches, and 24 through 36 inches. And when we do these studies, we often see at the beginning of the season with the controlled release fertilizer treatment that there is generally a large kind of drop off at the beginning because you're applying all of the starter and the controlled release fertilizer in that treatment all at once at the beginning of the season around planting. So you see that big drop off with the controlled release fertilizer treatment, especially in the 0 through 6 measurement. And kind of going along, generally, soil nitrate was a little bit lower for most of these depths throughout the season in the controlled release fertilizer treatment compared to the conventional fertilizer treatment. So moving on to the on-farm trial, this trial compared side dressing ESN, which is a controlled release fertilizer product that has a thin coating. So it's only about a 50-day product compared to Harrell's fertilizer blend, which is supposed to stick around for about 90 days or so. It's more of a 3-month product. And I'm presenting these results to give you an idea of how we use these fertilizer products in the field. This isn't the perfect trial to really compare ESN and Harrell's. I think more data is needed for that, and I'll explain why. But the ESN treatment consisted of 15 gallons of 2390 as a starter. And then at around V8, we applied 420 pounds of 4400, which is the ESN product. And then there is a pre-tassel shot or injection of 25 pounds of 28005 through the pivot. So that's compared to the Harrell's fertilizer treatment, which was used as a control of 15 gallons of the 2390. And then the Harrell's fertilizer was applied at planting instead of at V8 because it's a 90-day product. And then that injection of the 25 pounds of 28005. So we were close in the total amount of nitrogen between treatments. And you can see in the picture on the right-hand side, this is pictures from Michael Mulvaney in one of his blog posts, where he did some research kind of looking at ESN and kind of measuring its release curves over time. And it was interesting how he found differences in whether the ESN was applied to the soil surface broadcast or whether it was incorporated. And he found different temperatures, soil temperatures down at 1 or 2 or 3 inches or so compared to at the soil surface. So that was why he found different release curves depending on application method. So in the yield results from this season, or from the 2021 season at the research center, you can see that they're very low. We were getting at most just a little bit above 120 bushels to the acre. And that's due to this being a very late planting. This was planted in late May, early June, and we had a lot of disease and pest pressure. So this was a late trial. So that's one of the reasons we think we're seeing the very low yields. And you can see that we hand harvested 4 different replicates of the ESN, and we're comparing that to the control of the Harrell's fertilizer, which was machine harvested. So this isn't perfectly apples to apples in terms of how we measured yield either. Plant tissue nitrogen was measured throughout the season, and you can see that in the beginning of the season, there was a little bit more of a spike with the Harrell's control release fertilizer, and that makes sense. It was applied earlier, and then at the rest of the season, it was pretty similar compared to the ESN and the Harrell's. So extension impacts and conclusions. So some of the extension impacts I've had with this Columbia County grower cooperator over the years include the fact that he's adopted cost share from the Suwannee River Water Management District, both on soil moisture sensors and on a side dressing rig. That's why we use the side dressing rig this year. He now has one. In the past, he was using a broadcast applicator. He uses the soil moisture sensors and he credits them for saving him 40% of his irrigation water. In the past, he was irrigating 1 inch of irrigation at a time. Now he's irrigating more about 0.6 inches of water. And for his efforts as an environmental steward, he was recognized by Florida Farm Bureau with This Farm's Cares Award. Other conclusions are that we found similar yield results from the control release fertilizer and the conventionally fertilized corn. Control release fertilizer are a useful tool for managing nitrogen, especially during heavy rainfall events. And these trials we hope will be helpful if there's ever evaluation of cost share for control release fertilizer. That's a discussion we hear between extension and agency folk in the region. I'm unsure if that will ever be the case, but there's a lot of agricultural cost share out there. There's been discussions about maybe offering cost share on the technology of the control release fertilizer. And now my last slide, I just want to say thank you to a lot of people who've worked with me on these trials, including Dr. Lakesh Sharma of the Soil and Water Sciences Department, Chrissy Fletcher of St. Johns County Extension, Paulette Tomlinson, my livestock and natural resource agent here in Columbia County, and then all the North Florida Research Education Center, Suwannee Valley staff and faculty, especially Joel Love, the BMP coordinator. I'd like to thank Dr. Vivek Sharma, who will be funding trials this year to continue working with this Columbia County cooperator. Dr. Zane Grabau, who's been very helpful when we've run into nematode issues on farm. This has to do with BMPs because we don't want to find ourselves in situations where we're trying to out-fertilize or fertilize ourselves out of a nematode issue. So we've run into situations where Dr. Grabau has been very helpful. I'd like to thank Harrell's Fertilizer and Nutrien for participating in these trials, and then for funding from Florida Department of Agriculture and Consumer Services and the Stetson Sustainable Farming Fund. Thank you.
Thank you, Jay. Emily, can we have the post-test and the CEUs? Perfect. Folks, please fill this survey. This is the last presentation. And if you have any question related to any of the presentation before this, please ask that question now, or you can reach out to me after the session is over. I'm very thankful to everybody for your presence today, all the speakers for these wonderful presentations. I have been asked some of the attendees that if you can share your presentations with me, then I will use those presentations put up on the BMP website perhaps, and if there is any copyright issue, please remove those slides from your presentation because those are some of the sites, some of the presentation going on the website. With that, I do not see any question. I have added the files in the chat box for the category of your CEU. If you go on the top right-hand side, you can see whether it's a soil, water, or nutrient management credit. Please use those for your credit additions. With that, I would say thank you very much. Thank you, Emily. Thank you, Dr. Dukes, for your input and help and support for this session. We'll see you all for next week on April 12th, the same time, 9 to 11. And we have a very good session as well at that time where FDAC is going to present us any update on a BMPs and some of the bills that are in session, including SB 1000. If you have heard of it, please go and read about it on the Google website. And is there any other query or question? Please reach out to me through my email. Thank you very much, everybody. See you next week.